Welcome to EDU World Space.
So we know that the object distance is greater than the focal length. We know that magnification is simply minus image distance by object distance, which means image distance is simply minus m times object distance. Now that we have this, we can simply use our equation 1 by f is equal to 1 by dO plus 1 by di. Now 1 by f is equal to 1 by dO plus for di we substitute our equation giving us minus 1 by m dO, which means 1 by f is equal to, if we take 1 by dO common here, or we need to find m, so we'll simply send this this term over here, giving us 1 by f minus 1 by dO is equal to minus 1 by m dO. Now simply multiplying the whole equation by dO, we'll see that dO by f minus 1 is equal to minus 1 by m. Now simply taking the inverse on both sides and multiplying by minus 1, we'll see that this is equal to minus 1 by dO by f minus 1 is equal to m, giving us m is equal to f by f minus dO. This is the formula for magnification. Now once you have this, you can simply plot it using any plotting software. It will look something like this. If you, let's say, take focal length to be 1 meter, then on a scale of 1 meter to 2 meters and so on, the magnification will look something like this, where this is 0 and this is around minus 10. That is, the curve asymptotically falls to infinity, minus infinity, as you get closer and closer to dO is equal to f. The x-axis is dO. Now for part C, we want the object to be the same size, which means we want m to be minus 1. We want m to be minus 1 because the image is real, which means image distance and the object distance are both greater than 0, which means magnification must be negative because m is minus di by dO. So we know m is equal to minus 1. Now simply using our formula that we found here, we can write f by f minus dO is equal to minus 1, which gives us f is equal to dO minus f, which means object distance is 2 times the focal length, which in this case is simply 0.90 meters. Now that we have this, it is very clear from the graph for part D that if we want the magnification to be very large, we need to be in this region where the magnification goes to infinity, which means we want the object very close to the focal point. That's it. But also remember that this is just beyond the focal point. If this is your lens and this is your focal point, your object needs to be somewhere here, not somewhere over here.